Here is everything we need to make a light emitting diode circuit. So here I have a red LED, I have a 100 ohm resistor, I have a few connecting conductors, I have two AA batteries, I have a AA battery holder, which would be 3 volts when they're in series. I have my single pole, single throw SPST toggle switch, and I have my solderless breadboard. Now let's construct our LED light circuit. Now first off, I've already connected the positive lead of my battery pack to this switch terminal, and then we're going to connect this conductor to the other switch terminal. We have to use our screwdriver again. I'll just gently tighten that. And this time I'm going to connect the positive to the positive bus bar of the solderless breadboard. And next we're going to connect the negative terminal of the battery pack to the negative power rail of the solderless breadboard. And it's a very skinny wire, so it's a little difficult to get in the hole, but I think I managed to get it in a little bit there. Now next I'm going to insert the LED. Now we have to pay careful attention to the LED. You can notice that there's one lead that is longer than the other. Now that's very important. That denotes the anode, or the positive material type lead of the LED. And we have to be careful about polarity. We have to make sure the polarity is correct, otherwise the LED will not work. So I'm going to put the anode, the longer lead, on the side closest to where my positive power is coming from the battery, and I'm going to insert my LED across the channel. So the anode is in row 1E and the cathode of the LED is in row 1F. Now next I need to get the positive connected to the anode of the LED, so I'm going to use another connector wire, and I can insert it anywhere on the positive bus. So I'm going to insert it there, and then I'm going to go to 1A. And now I need to connect the negative side, but that's where I need the resistor. So I'm going to connect the resistor between the negative bus and 1I. And that should complete our circuit. Now we're going to do a check of our wiring to make sure everything is correct. So the positive lead from the battery pack goes to our switch, and then the other terminal of the switch goes to our positive rail. The positive rail goes to this conductor, which goes to 1A, and then the current will flow to the anode of our LED. Current will go through the LED producing light and down to 1F, and then the current will go to 1I where our resistor lead is. The current will flow through the resistor down to our negative power terminal, back through the negative lead of the battery pack. So now we're ready to insert our batteries. The circuit looks correct. So we're going to insert our batteries. There, my batteries are inserted. Now I'm going to turn the switch on, and you can see the LED lights. When I turn the switch off, the LED is off. On, off. So there you go. We've made our own LED light. And it's not very bright. This would not make a very good flashlight or torch, but it's a good indicator that a circuit is on or off. And now I'm going to show you how you cannot hook the LED up in reverse polarity, because it won't operate if current tries to flow backwards. So what I'm going to do simply is turn the LED leads around. So now I'm going to put the anode on the negative side of my circuit and the cathode on the positive. So now our LED is in reverse polarity and it will not conduct in reverse polarity. So now I'm going to turn the switch on and you see it does not light. So an LED in reverse polarity, current will not flow and it will not light. So now I'm going to correct my circuit, put the anode on the positive side once again, cathode on the negative side, and try it again. There we go. So you have to make sure you have the correct polarity for your LED. And this LED, the positive side is denoted by the longer lead, and sometimes they'll also have a notch or a flat spot on the negative side denoting the cathode. So sometimes there's two clues as to polarity for LEDs. Now you might be wondering, why did we use a resistor, a 100 ohm resistor, in series with the LED for this circuit? And also, why did we use only a 3 volt battery instead of the 6 volt battery that we had for the 6 volt lamp? Well, the answer is it's because of the voltage and current ratings of this LED. And we will look at the data sheet to explain the reasons why the circuit was built this way. So here we have a data sheet from the internet and on my computer, and it's for a red LED. Not exactly the same one, but it's for a 10mm LED. This one happens to have a much higher luminous intensity than the one that I have. But what we're interested in is the forward voltage on this line. Voltage forward. It says minimum is 1.7. So that means a 1.5 volt battery is not enough to make this LED light. And then maximum is 2.5 volts. So that means 3 volts is too much for this LED. You could burn it out quite easily if you exceed the forward voltage. And it says typical is 1.85 volts. So I just decided for myself, I make the LED run on 2 volts. It's a nice even number. And for the forward current, it's saying the recommended operating current is 20 milliamps for this particular LED. In my case, I usually like to run it at 10 milliamps for my typical low power LEDs, and it'll work quite fine. So using those two parameters, 2 volts and 10 milliamps, it was easy to use Ohm's law to select a 100 ohm resistor, because that would make the resistor drop 1 volt at 10 milliamps. And using Ohm's law, if we go voltage divided by current, so 1 volt divided by 10 milliamps, which is 0.01 amp, equals 100 ohms. So that's the reason I chose the 100 ohm resistor. And the reason I chose the 3 volt battery was because it was the lowest possible voltage that I could use to make the LED work at 2 volts. If I just used it straight at 3 volts, we would burn out the LED if we did not have that resistor to drop the voltage and limit the current. Now I will show you the actual voltage drop across the LED and across the resistor of this circuit to see how well the practical matches the theory. So I'll turn on the circuit. So now our LED is on, and we'll measure our full battery voltage if we go across the LED on the positive side and the resistor on the negative side. See, we have 3.00 volts. So now I'm going to measure the voltage drop across our LED, 1.865 volts. And that's very close to what the manufacturer said the typical forward voltage would be. Their data sheet said 1.85 volts. So now let's see what the voltage drop across the resistor is. And this is a 100 ohm resistor. We have 1.146 volts. And it's changing a little bit, 1.147. And we calculated for a 1 volt voltage drop, but that was assuming a 2 volt drop across the LED. So for practical purposes, our circuit is working very well. So I hope you've enjoyed this LED project, and I hope you can enjoy building your own light, whether it's an incandescent or an LED or both. Have fun. And we will see you for the next lesson, lesson number 8.